Hey everyone, and welcome to the awful world of mastering chemistry. Now, that system's not actually that bad. It's just trying to get yourself acquainted with how this drawing program works in mastering chemistry, and that's one of the things I want to show you with here. So I'm going to try not to take forever to explain this example problem, and if I do, I apologize already, but there's always double speed on YouTube, so you can watch me a little bit faster and make me sound like a chipmunk, and everything will be okay. All right, so this particular problem says draw the Lewis structure for CH3O with a minus. Okay, so I'm going to have to go into the Mastering Chemistry software, and I'm going to have to learn how to draw these molecules because, let's face it, folks, that's what organic chemistry is all about. It's about drawing, and it's about naming. I mean, that's half the battle if you're an 80s kid, right? So the very first one that we're going to be looking at with this example problem is CH3O with a negative charge. So I'm just going to walk through the process of how I draw these structures in Mastering Chemistry, and that might be a little bit different than yours, but that's okay. You can do these multiple different ways. I just kind of know what works for me the best, and that's what I'll do. So down here at the very bottom, you'll see some element symbols. These are the majority of the ones that are used quite often in organic chemistry, and that's why they bring those to the forefront. So carbon, hydrogen, oxygen, nitrogen, sulfur, phosphorus, fluorine, bromine, chlorine, iodine, and X, which means you just don't really know what it is. So I think that I deserve a 100 on that organic quiz with general chemistry information. All right, so if I go to the more section, though, you will actually see a periodic table that will show up, and if those atoms that you need, especially if we're in the world of like organometallic reactions, and those are typically not very common, if you need to go into the periodic table and you need to choose these element symbols, that is where you'll do that. All right, so then we can hit close. So that is the option for you if you do click more. If you click on one of these atoms and just click on the blank screen, then you're going to see that that atom shows up. I mean, it's as simple as that, right? So there's my carbon, and here's a hydrogen, and there's an oxygen, and there's a nitrogen. So those allow you to assign individual atoms on the sheet. Now, does it matter how far apart they are? No, it really doesn't matter how far apart they are. The system is going to recognize that, meaning that if I need to connect that carbon and that hydrogen together, well, over here it looks like there's a single bond, and there's something called a double bond, and here's something called a triple bond. And if we get into stereochemistry, I see solid wedges and dashed wedges, meaning pointed toward my face and pointed away from me because they don't want to look at me. So here is this single bond, and if I click that carbon and just kind of drag it out, you're going to see what it did. This is very bothersome, right? Well, by clicking the carbon and dragging down to that hydrogen, which is what most people decide to do, it automatically drew this random line with a nitrogen on it. And that's not exactly what I want. Well, that's actually not the way to use the system. And the reason that it did the line to the nitrogen is because I had clicked on nitrogen, and then I had clicked on the line, and I clicked on carbon in order to initiate this bond that I wanted to draw, but I wanted that bond to go to hydrogen, and that's not the way that we do this. All right, so I'm going to kind of undo all of that garbage. I don't want that on there. All right, so let's say that I've got this carbon and I want to draw 3 bonds, each one to a hydrogen. So this is how I do it. There's my carbon, and then down here I'm going to click on hydrogen because that's what I want to draw next. And I want those to be single bonds, so I've chose that option to the top left-hand corner. And now I just click the carbon. So 1 carbon, 2 carbon, 3 carbon. Look how fast that was, right? So I don't want you to spend a lot of time putting atoms on a sheet, drawing individual bonds to them. The system does this somewhat automatically for you, and that's how you get that to do that. So the 4th bond to that carbon is actually going to go to an oxygen. So what I would do is that I would go and click the oxygen down here, and then I'm going to first choose a single bond, and I'm going to click that carbon that I want it attached to, and then that's what I'm going to do there. All right, so my carbon now has a full octet, right? 2, 4, 6, 8. Who do we appreciate? Carbon! So there's my octet of carbon, and each one of these hydrogens, they have 2 electrons to them due to the bonding electrons. So that hydrogen has two, and that hydrogen has two, and that hydrogen has two, and that's all that that one needs. But the oxygen here doesn't really have the full octet. And if you did the Lewis dot symbol, you would notice that you need to apply some electron pairs because this system wants those. It likes those. It wants those free pairs of electrons drawn on structures. So here's a single electron, and there is a pair of electrons. So I'm going to click the pair of electrons, and I'm going to go up here to this oxygen. I'm going to click it. Boop, and there's two electrons, and boop, there's another two electrons, and boop, there's another two electrons. So that gives me 2, 4, 6, 8, and we appreciate oxygen now at this moment. So here's the thing, this carries a negative charge. If you did the Lewis dot kind of a schematic about totaling up the number of protons, you would have seen that we needed extra electrons in order for that oxygen to kind of work itself out as far as bonding and octet numbers. And you might be inclined to go ahead and say, that's my structure, and then hit submit. And then when you do that, it's going to say, wrong, try it again. And the reason is because we're leaving out something pretty important. And this structure says negative. And it wants you to kind of draw where that negative is going to be located. So here in the bottom left-hand corner, you'll see a positive and you'll see a negative. So I know that this thing is going to carry a negative charge. So I will go here and click on negative. And then up here, I'll click on this oxygen. So I'll hover my mouse over the O and I'll click it. And it gives me a nice little negative sign. Now, I can type in the -1 there if that's what it is, or if it's a -2 or a -3, I can key in that value. On the positive side of the house, it works the same way. I'll click the positive symbol, click on the atom, a positive will begin to blink, and it's +1 or +2 or +3, whatever you want. So now I'll just key in -1, and it actually doesn't even draw the 1 for me, right? Most of the time it's just going to leave a negative value that's there, and then I'm going to scroll down and I'll hit submit again, and this says ta-da, you got it right. So that is how you use the mastering chemistry system in order to draw these structures that you will begin to experience in the homework portion of the course. Now, the other thing that I've not talked about yet are double bonds. That's not a big deal. So in the next example, we'll go over double bonds and triple bonds, and I'll also go over whatever this square bracket means. So I'm going to pull up another example, just bear with me, and then we'll go through the motions of drawing a new structure that maybe will require you to do something else to it. All right, so here's another example, and this one says, draw the Lewis structure for CH3N2+, and the 3 hydrogen atoms are all attached to the carbon. Well, they're giving me some hints as far as the Lewis dot structure goes, because maybe this is very early on in the semester, and maybe I want to try to put hydrogens on the nitrogens. But this problem is telling me, no, you can't. The 3 hydrogens are all attached to the carbon. Well, that's a very good place to start, don't you think? So I'm going to click the carbon, and then I'll click here. There's my carbon, and then I know there's 3 hydrogens that are attached to that carbon. So down here at the bottom, I'll click hydrogen, and then up here, I'll click the single bond, and I'll go boing, boing, boing. Oh, whoa, what happened there? Right? I don't want that. Well, if you make a mistake, no big deal. There's an undo button right up there that will undo some of those steps for you. And then I can click the undo button again, and that takes me back down to a single bond. And then I'll click the carbon, and boing, there's my 3rd hydrogen. So we're going to talk about that double bond and triple bond in just a second. But here's my CH3 portion of the structure. Now, I know there's 2 nitrogens that are left over. Hydrogens can't have any more bonds. The carbon can only have 1 bond, and that is it. And that 1 bond is going to go to my 1st nitrogen, no more than that. And then that means that this 2nd nitrogen that's on the structure, the only place for it to go is also there on that nitrogen. That's what can actually take that, right? So if I take a look at the structure here, I get valence of 4 from carbon, and I get 1 from each one of the hydrogens, so that's 4 plus 3, and that's going to give me a total of 7. And then as far as nitrogen goes, right, if I go here to the periodic table and I take a look at nitrogen, this is in column number 5. So that means that nitrogen has 5 valence there, and there's 2 of those. So, okay, there's 4, and then there's 5, 6, 7, and then there's going to be another 10 from the nitrogen, so that's 17. But it looks like it's a positive charge. And that positive charge means that I need to take away 1, not add 1. I don't need to add an electron, I need to take 1 away. So that way it can give a positive charge. I'm taking a negative away. So that means there's 16 in total. All right, so 2 and 4 and 6 and 8. And then there could be a 10 if there's a double bond that's there. And notice what I did. I just left this on a single bond and I just clicked the line, right? If I click the line there, that changes it to a double. I don't have to choose the double here. And then if I click the line again, it changes it to a triple. Once more, I don't need to click the triple there. And then if I click it again, it goes back to a single. All right, so that looks like that might be a little okay. It looks like it's a little bit quicker, it's a little bit more convenient, and that's exactly what I do in the Mastering Chemistry section. I don't actually switch over to the double and triple bonds here. You can, but to me, it's just easier to start with the singles, just like I would do on a sheet of paper, draw the single bonds first, and then go back and add to them a little bit later. All right, so 2 and 4 and 6 and 8 and 10 and 12. And then if I click this again, well, there's 14. And then it looks like I've got 2 electrons left. That nitrogen can't have any more, right? There's a bond here, and then there's 3 bonds there. So there's 2, 4, 6, 8. We appreciate nitrogen. And then this nitrogen here on the end, well, that one just has 2, 4, 6, and that is it. And we've got 2 left, and what perfect place to put those than on that nitrogen that is right there. And then we look at this thing and say, well, it looks like all of my lines and my dots have been taken care of in the Lewis dot. So we have a total of 16, and there's 2, and there's 4, and there's 6, and there's 8, and there's 12, or 10, and then 12, and then 14, and then 15 and 16 from the dots. All right, so it looks like I'm going to be okay, and then I hit submit, and it's going to go, wrong. And you're going to look at this structure and go, oh, shoot, I forgot to put my positive there. And I'm going to click on that, and then I'll be like, well, where does the positive go? Well, maybe here on the end. That's typically where people try to put it, and then if I type in the 1, that's fine. It just ignores the 1, and I go back down, and I hit submit, and it's going to go, try it again. So I knew that was going to be wrong, but that's typically what people gravitate toward, and that's a misconception. That does not happen there. So what if we make a mistake? Well, there's a little erase button right up there. Look at that. It says erase. So I'm going to take my mouse and I'm going to gradually go over the positive, and it highlights it in blue, and I get that out of there. I do not want it because this nitrogen actually doesn't have a positive charge. My formal charges is what I'm looking for. Nitrogen has 5 valence. So 5 minus 1 from that bond, and 1 from that second bond, and 1 from that third bond, and 1 from that dot, and 1 from that dot actually gives this nitrogen a formal charge of 0. That is not where the charge is taking place. However, with this particular nitrogen, we have 5 valence. To calculate formal charges, I've got 5 valences there, and I subtract 1 from that bond, 1 from that bond, 1 from that bond, 1 from that bond. That's 5 minus 4, which is a positive 1. So that's actually where my positive is going to go. It's going to go right there on that nitrogen that's somewhat internal to the molecule. That's where my formal charge of positive is going to go. And again, it's all based on valence and formal charges. All right, so now I'm going to come down here and I'll hit submit, and it says, ding, ding, you've got it right. So that's good for me. I got another question correct. I get points for that on a homework assignment. And those are some of the typical problems that you might see when you start doing these Lewis dot symbols. What is this bracket? Well, this square bracket is something that I can choose. So let's just kind of go back and take a look at another example problem. Now that this one's kind of entered, it's accepted that answer is a correct answer. Doesn't really like for me to change that, and that's okay. But in the next example, I'm going to draw a structure and we're going to use this bracket. All right, folks, so we'll do one last structure just so you can kind of watch me go through the processes again, but this time I'm going to use a bracket. Even though this problem doesn't need a bracket, I'm going to choose the bracket symbol so you know how to actually use it when you draw these structures, if you're required to use them. So this example says, draw the Lewis dot structure of CBr4. All right, no big deal. I'm going to start with my carbon, and there's my carbon. I don't have any bonds that are here, so that's what I need. I just need the carbon on there first. It gives me a place to start. And now I need 4 bromines that are probably all around that carbon, right? 2, 4, 6, 8. So I'm going to click my bromine down here at the bottom, and then I'll click my single line up here in the top left, and I'll go boing, 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 and there is my 4 bromines on the carbon. So 1, 2, 3, 4. And now I need to kind of do a total valence electron count. So my bromines have 7. 7 times 4. What is that? 28, 20, and 4 from a carbon, 29, 30, 31, and 32. So I've taken care of 2, 4, 6, 8. And now I need to apply free pairs of electrons around the entire structure. So 10, and 12, and 14, and 16, and 18, and 20, and 22, and 24, and 26, and 28, and 30, and 32. Notice what I do. I try to make it symmetrical, just like we did it in the lecture portions when we were drawing them by hand. And now if I take a step back and I look at this structure, my carbon has 2, 4, 6, 8. We appreciate carbon. And then my bromine has 2, 4, 6, 8. We appreciate bromine. And all 4 are the same way. So this particular structure is going to be the correct Lewis dot structure for CBr4. But let's pretend for a minute that the question has a bracket around it. Or let's say that I need to put brackets around the entire molecule because the entire molecule is carrying with it some type of charge, and that charge is not localized on one atom, but the entire molecule. So how would we do that? If you run across those problems, here is the bracket. You need to click the bracket here at the bottom, and then just click the structure. Notice that the structure highlights all in blue, and when you click the structure with the bracket symbol highlighted, it will put brackets around the entire thing. So that will let a viewer know that this molecule carries with it a charge, and that charge is maybe spread out through the entire molecule and not just on one particular atom in particular. So with that said, those brackets will often come with charges, either positives or negatives. And just like before, you'll come down here to the bottom and you'll click a negative. There's my negative. And then you'll come up here and click the bracket symbol. If you click the atoms, it's going to assign the charge to that particular atom. But if you want the molecule to be charged or to be represented, you need to click the bracket that has that molecule on the inside. So by doing that, the brackets highlight in blue. Let's say that I want this to be a -2 charge, even though that's wrong and doesn't make any sense. I'm just showing you an example. And then I'll click out of that, and that will convert that over to a -2 in the top right-hand corner. So that lets me know that the molecule as a whole carries a -2 charge, and that -2 charge is not necessarily localized with one particular atom, but spread across the entire molecule as a whole. All right? So that's a little bit about how to use Mastering Chemistry to draw these structures. Again, if you make a mistake, there is an eraser button up there at the top. Just erase the things that you don't need. Those items will be highlighted in blue. Just click on them, and whatever is in blue, they will go away. You can zoom in on these molecules, of course, by just taking a look at the magnifying glass and keep zooming in if you want things closer. Of course, you can zoom out as well, and then zoom fit just basically zooms in enough for the entire molecule to kind of be represented, and that way you don't have to squint your little bitty eyes to look at these structures. If you do want to draw a molecule and then be like later on, oh gosh, I shouldn't have drawn it there, I should move it because there's other things that it wants me to do, just click the dotted box up here, and then click and hold down your mouse button and highlight the entire molecule, and then kind of come over the one of the atoms with your mouse and click down while it's highlighted in green. And you can move that anywhere that you want to move it at that point. Whenever you're situated with where you want that molecule to go, just let up on it and then just get rid of it. And that will lock that molecule back into place on the electronic sheet of paper for you. All right. Okay, so good luck with mastering chemistry. It's just an introduction on how to draw these structures. You're going to do quite a bit of this, actually, and I think it's important for you to kind of get this experience using this electronic software. It's a little bit easier for you to draw. It's a little bit easier for me to grade, honestly, but, you know, don't shy away from drawing it by hand as well, because we need to know how to do that, too. Sometimes computers are not going to be there. All right, so if you got questions, let me know. You know how to get in contact with me. Here's your Mastering Chemistry lesson. I'm sure there's going to be more. Bye-bye.